Hello friends, this video on solid states part 6 is brought to you by examfear.com. No more fear from exam. Now we'll discuss about the classification of crystals. Till now what we have discussed? We have discussed what are crystals, what are amorphous, right? We also discussed a little bit about polycrystals. Now then we told that in this chapter we'll be focusing more on the crystals because the nature of is crystalline and most of the things we see around us are crystals. So the crystals, based on the nature of the intermolecular force operating between them, based on the nature of intermolecular force operating between them, they are classified as molecular, ionic, metallic and covalent solids. There are four further classification of crystals. We'll discuss about each of these in detail: molecular, ionic, metallic and covalent solids. In fact, the molecular solids are further classified into non-polar molecular solids, polar molecular solids, hydrogen bonded molecular solids. Ionic solids are not further classified, and metallic solid also doesn't have any further classification. And then we have this covalent solids, they are also called network solids. This is my typical classifications of solids, the crystalline solids: 1, 2, 3 and 4. The molecular solids are further classified into 4 different categories. Correct. So let's start with molecular solids. See, molecular solid is a solid composed of molecules. Please note, as the name suggests, molecular, that means we are talking about the molecules that are held together by van der Waals forces. Right? It has molecules held together by van der Waals force. Correct. So van der Waals force are London force, dipole interaction, and dipole and induced dipole force. We'll talk about these things in the next few slides. These forces are weaker than the covalent or ionic bonds actually. So generally the molecular solids are soft and they have low melting points, right? Because these forces are told by, I'll say, weak force, so they are generally soft and low melting point, right? And pure molecular solids are insulators. The pure ones are insulators, but actually you can make them insulator by doping it. We will discuss about that, how to dope a particular solid to make it to change its property. So the examples can be my hydrocarbons, my ice, solid carbon dioxide. So those are my examples of molecular solid, right? White phosphorus, sulfur. I can have my solid halogens, for example, chlorine, hydrogen, iodine. Correct. These are my molecule solid, right? N2, O2, SO2, ice, solid carbon dioxide. So if you see, in ice also we have this water molecule is one entity, and there are so many water molecules, they are linked by hydrogen bond. Correct. So here the entity we are talking about is one molecule, right? There are so many molecules linked together by weak van der Waals force. Correct. So since the classification of molecular solids are polar, non-polar, and we have this van der Waals force also, we discussed about these things in the earlier chapter, but let's do a recap of these kind of stuff before we move ahead and try to understand the different types of molecular solid. So let's talk about the intermolecular force. As I told, inter word is similar to internet, right? Internet. That means anything that is acting between the particles. So they are force of attraction or repulsion acting between particles. It is not among. For example, water I have, right? I'm not talking about the force between hydrogen and oxygen. I'm talking about the force between this water and this water. So The way I differ is intranet is intramolecular, that is within the organization, or within the same molecule you have different atoms. The fourth atom between them, and intermolecular is like internet. I mean, two different organizations, and you can just interact, right? So two different molecules, and there's a force between these molecules. They call intermolecular. So intermolecular force is a force of attraction or repulsion acting between particles, right? And sum of all the attractive or repulsive force is called van der Waals force. You add and subtract all the force, what you get is van der Waals force. And there are various types of van der Waals force. They told London force or called dispersion force. We have something called dipole force. In dipole force, we have hydrogen bond, and we have something called dipole and induced dipole force. We have discussed these kind of things. So let's discuss once again dispersion force or London force. They are generally exhibited by non-polar molecules. Why? Because of the temporary movement of electrons. I'll show you how. And their magnitude depends on the polarizability of the particle. For example, I have this oxygen. Now, if you see, each of these has 4 electrons each. Now, what happens is these electrons move. What happens is this guy gets slightly negative charge. This has slightly positive charge, right? Because electrons in this oxygen. Here also, since oxygen moved toward this oxygen, this gets slightly negative and slightly positive. Now, if you see slightly negative and slightly positive charge here, there will be some force of attraction between these two. Correct? This is my London force. They are very weak force, and their magnitude, as I told, depends on the polarizability of particles. In this case, my oxygen. And this is because of the temporary movement of electrons. Correct? And this happens. This is observed in a particular compound. Now, if you see the dipole force again, so I have HCl, for example. This has slightly negative charge because the chlorine is more electronegative. Hydrogen is slightly positive charge, less electronegative. So if you see here also same thing will happen. So this hydrogen, this chlorine will have force of attraction. Correct? This is called dipole force. This acts between molecules. They have permanent dipole. Correct? Because HCl will have permanent dipole. We discussed about these things, so I'm not discussing in details. So this interaction is stronger than London force because they are very weak force. But again, this is still weak. They are weaker than ion-ion interaction. We'll see that, for example, Na plus and Cl minus will have more strong force because the charge on them is more. This is partial positive and partial negative charge. This is real positive and real negative charge, right? So that way. Then we have the hydrogen bond. So for example, HF, right? And this is part of dipole force, but this is only with high polar molecules like NH, OH, HF. So in this case, if you see, the electronegativity difference is more, right? And this is limited only to oxygen, nitrogen, fluorine. This is the example of hydrogen bond. Also, you can see water also has the same hydrogen bond force. Slightly negative, slightly positive, slightly positive, slightly negative, slightly positive. Right? They'll have a force of attraction between them. Sorry, this and this. Or this and this, like that. So this is my hydrogen bond. They also quite strong force. Then we have dipole and induced dipole force. So this is type of force operates between the particles having one has the permanent dipole, right? And the other is lacking a permanent dipole. So this has permanent dipole. So this particular will induce this. If you see, this is 1 and this is 2. 1 is having permanent dipole, 2 is not having. The 1 will induce a dipole on 2. 2 will also have a dipole now, and then there will be a force of attraction between them. Correct. And again, induced dipole depends on the polarizability of this 2. And molecules of large size can easily be polarized. So if it is large, it is easily be polarized. Then let's also discuss the polar and non-polar molecules, because we'll talk about the polar and non-polar molecular solids. See, non-polar means there is no charge, right? And polar, if you see, HF, if you see, F will have slightly negative, slightly positive. This is slightly negative, slightly positive. So the electronegativity difference is more, it will be polar. Right here also nitrogen will have slightly negative charge, slightly positive, slightly positive, and slightly positive. Oxygen will be, this will have slightly negative and slightly positive because of resonance. So these are polar molecules which will have partial positive, partial negative charge, maybe because of resonance or difference in electronegativity. Non-polar molecules are almost neutral. For example, if you see carbon, hydrogen, the electronegativity difference is not that much, so all these carbon, hydrogen atoms are almost neutral. Right? Oxygen also same thing. Nitrogen also same thing. So polar means they have poles, positive charge, negative charge poles. Non-polar means they don't have any poles, charged pole. So having understood, having done the recap of polar, non-polar and different kind of van der Waals force, let's again start with the classification of molecular solids. As I told, molecular solids are nothing but solid composed of molecules held together by van der Waals forces, right? And there are different types of molecular solid. The first one is non-polar molecular solid. So good example is hydrogen, iodine and chlorine. They are non-polar because they are same compound, right? So there is no chance of electronegativity difference between them. So they don't have any chance. They are held together by a weak dispersion force or London force. So they are soft, right? They are non-conductor of electricity. Since they are soft, they have low melting point, and they are generally liquid or gas only at room temperature or pressure. They are generally liquid or gas at room temperature or pressure. I think this is iodine, solid iodine, yeah. So this is the molecular solid structure. Actually, if you see, these are, I can take it as iodine, two iodines, and they are held together by some force, right? So this is how it is. We'll talk about the structure in detail in the next few slides. Just understand this is how it looks, like a cuboid or cubic shape cell which has some molecules, right? These molecules, if you see, are held together by the weak van der Waals force, like that. Correct. The next is the polar molecular solid. For example, HCl. Right? It has this permanent dipole, and these have these poles. They're polar molecular solid. They have strong, since they have poles, they have strong dipole interaction. They are also soft, and they are non-conductor of electricity. They are also soft, and they are non-conductor. Correct. Again, here also most of them are gas at room temperature and pressure. The next is hydrogen bonded. A good example is what? Ice. So in ice I have H2O, and these are all bonded by H, hydrogen bonded, hydrogen bond. They are also non-conductor, and we'll tell you why, because they don't have any free electrons. They are liquid, and they are all soft solid at room temperature. They are liquid or soft solid at room temperature. This is the structure of water. Actually, if you see, this is my oxygen, this is my hydrogen, this is my hydrogen, this is one water molecule, this is another water molecule. If you see, they are interacting, correct, by this hydrogen bond. And here also, if you see, the structure is like this. In one cell we have so many water molecules. We'll talk about the structures in the next few slides. So these are my crystalline types, molecular solids. The molecular crystalline solids type: hydrogen bonded, polar and non-polar. Only three different types of molecular solid. Right? In hydrogen bonded, we have hydrogen bond. In polar, we have poles, for example, H plus Cl minus. In non-polar, we don't have any poles, for example, iodine, chlorine. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.